Good morning, children. Now today we are going to talk about EMF, that is the electromotive force and potential difference. Now what is the difference between the two? The very first thing is, when we say electromotive force, so you have to be very clear that it is not the force. It is again a potential difference. But how? When the source of potential difference is not working in the circuit, or you say the circuit is closed. Now this difference will be clear from an example. Like suppose when you go to the market and you buy something, like for example you buy a cell or a motorcycle. Then there is some standard value of say motorcycle efficiency is given to you. For example, efficiency is given that it will run 70 kilometers in 1 liter of petrol. And on cells you have seen that it is written in small cells 1.5 volt. So that means it is going to provide you the potential difference of 1.5 volt. Now what actually happens is, the actual value is something different. Whenever the motorcycle will be used, it will never give you, say if it was given 70 kilometers in 1 liter, it is rarely going to give you 70 kilometers in 1 liter. Apart from that, even the cell, suppose it is given as 1.5 volt. These are the standard values. These are the standard values. But when they will come in use, as soon as they will come in use, the value will become different. So this original value, or the original value of the potential difference between two terminals, is known as EMF, whereas the actual potential difference is known as terminal potential difference or only potential difference. See, as soon as this 1.5 volt source will come into circuit and some current will be drawn from it, the internal resistance of the cell also comes in the circuit, which we usually neglect, being very small. But what happens as we keep on using the cell, this internal resistance keeps on increasing because of the reactions, and also the chemicals inside the cell also start getting decreasing. So 1.5 volt is the standard value, but as soon as it will come in the circuit, it will give me a value less than 1.5 volt. So this standard value is known as EMF, and the actual value is known as terminal potential difference, or simply potential difference. Now this will be denoted by V, and EMF will be denoting by E. And you shall not get confused with this E as electric field now here in this case. In this particular expression, we'll be using E for EMF. You can also distinguish it by using in this manner. But later on, this sign or notation we'll also be using for induced EMF. So here we'll be using only E. You can do according to your convenience. Now I'll explain the difference mathematically also using a circuit. Suppose there is a circuit having a given source of potential difference. This one says EMF is E and potential difference is V. Now what is the difference between the two? See, once we'll talk about internal resistance and another is external resistance. Now external resistance is the resistance connected in the circuit across the terminals of a cell or any other source of potential difference. Potential difference means there is a difference in concentration of charges at the two terminals. Where the negative charges are there, it is said to be at negative potential. Where the positive charges are there, positive potential. Electrons will move from negative terminal to positive terminal, and by convention the current will flow from positive terminal to negative terminal. Now during this calculation, when we say V is equals to IR, what we are doing is we are involving only this external resistance in our expression. What will change if I take the internal resistance of this cell also into consideration? See, I already told you before, I think 2-3 days back, that these wires will have some resistance, but that are also being neglected. Since this is a conductor, the resistance will be very, very small. These are the connecting wires. So we are neglecting. Here also we are neglecting these distances of wire. But in case we take the resistance of the cell into consideration, then what will happen? See, the resistance of the cell is said to be an internal resistance. We'll be using the word internal resistance, and it will be denoted by small r. Generally in the circuit, if it is shown, it will be noted by small r. When drawn, sometimes it is drawn adjacent to the cell in the circuit, like this. They'll just write it over here. Small r is say 0.1 or whatever the values. So they will note it by small r, and in the question also they will give you that a cell of internal resistance R, say 0.1 ohm, is connected across an external resistance of given value. Or it may be denoted like this. Small r. This also indicates the value of resistance of this cell. And you know that as we keep on using a cell after the chemical reactions, the number of ions keeps on decreasing, the potential difference keeps on decreasing, and this cell is not to be used, and then we use new cells. Now, if this internal resistance is being considered, then what will be our value of R? Total value of R of the circuit. It will be R net will be equal to R plus small r. So when we are neglecting small r, the value of potential difference is known as E or EM. When we are including r, then the value is known as V. So when the cell is not in circuit, or rather circuit is not being used, or the circuit is open, then in that case, circuit open means no current is flowing in the circuit. Then the potential difference is known as E. When the current flows in the circuit, or the circuit is say closed, then we say V. So what will the value of V here? Now here E will be equal to I R plus capital R, and this will be equal to E is equals to IR plus capital R. This can be written as V. So V will be equal to E minus I. So this is the relationship between V and E. V is equals to E minus IR. From here you can also find out the value of small r. That will give you V E minus V upon I. You can type IR on this side. This will give you E minus V. So internal resistance can be calculated in a given circuit. Using this expression, you can do exercise 3.1 and 3.2 given in your NCERT book. So I think you might have understood the difference between EMF and potential difference. So the name EMF, not to be confused with force. This name is given because of some historical reasons. So it is not force, it is potential difference or terminal potential difference. Now we have talked about combination of resistors. We have also talked about combination of capacitors in unit 1. Now we'll be talking about combination of cells. Combination of cells. Number 1 we'll talk about it. Series. In series. Let us consider two cells connected end to end like this in series. Let the resistance be say R1 and R2. Let the potentials at point A, at point B and point C be say VA, VB and VC. We have to calculate what is the effect of this combination of two cells, say E1, the EMF E1 and E2. That means I have to find out the collective effect of these two cells. That is, if I want to connect only one cell instead of this two cells in series, what will be the value? See, this will be the final situation. With one R will not show it here, or we can show it also here. Say like this. R equivalent, E equivalent, and this is the point A, this is the point C, VA, VC. See, in series, current will remain constant. Current will remain constant. Now, VA minus VB will be equal to IR1. Current flowing through the resistance R1. Now, the formula which we have obtained just now was V is equals to E minus IR if the internal resistance is to be considered. So, potential difference will be now equal to, in this manner will be equal to E1 minus IR1, then minus VB, E1 minus, and one more, this is for VA minus VB, this point and this point. The second is between point B and point C, the separate potential difference. So, VB minus VC will be equal to E2 minus IR2. Current is going to remain same. I want to find out VA minus VC. You can write it like this also. VA minus VC. In this way also you can note down. So VA minus VC you can see can calculate it by just adding these two. This VB and VB will cancel out. I'll get VA minus VC is equals to E1 minus, I'll take E again first, E1 plus E2 minus I R1 plus R2. Now this is the total EMF and this is the total resistance. So what is the E equivalent? This can be written as E equivalent minus I R equivalent. So E resultant E will be equal to E1 plus E2 and R equivalent will be equal to R1 plus R. You can take this as two equations. That means when the two cells are connected in series, when the two cells of EMF E1 and E2 are connected in series, then in that case the equivalent EMF will be simple addition of the two EMFs and the resistance will be simple addition of the two resistance. That is, the internal resistance will also increase. Now suppose negative terminal would have been here and the positive terminal would have been here. Then the direction will change and accordingly you will get equivalent EMF is equals to E1 minus E2 or E2 minus E1 depending upon which one is the greater value. Now we'll go in for parallel combination of cells. Now in parallel combination, consider two cells of EMF E1, internal resistance R1, EMF E2, internal resistance R2, connected in parallel. Now in parallel what remains same? V remains same, but I becomes different. So let the current flowing through from the cell, say E1 is I1 drawn from the cell is say I1, and from this cell is say I2, then total current will be equal to I1 plus I2. Now I have to find out the values of I1 and I2 and substitute here and get the values of I. Now in the, you can take this point as AB. Now through cell E1, what will the value of V? See, V is same in parallel combination. So for this branch, V can be written as E1 minus I1 R1. From the second branch, you can take path 1 and path 2, E2 minus I2 R2. Now what I have to calculate from here? I1 and I2 and add them up. So what will be I1 from here? See, I1 R1 will be equal to E1 minus V. So I1 will be equal to E1 minus V upon R1. Similarly, from this equation, I2 will be equal to E2 minus V upon R2. Now we'll come to this equation. Total current shall be equal to I1 plus I2. I'll substitute from here. This will give me E1 upon R1 minus V upon R1 plus E2 upon R2 minus V upon R2. This is going to give me E1 upon R1 plus E2 upon R2 minus V 1 upon R1 plus 1 upon R2. Now we'll solve this equation. Again we'll compare it with this equation. This is the standard equation. We'll compare it with again this equation. I'll write this equation in this form and then I'll find out the equivalent E and equivalent R. So we'll solve it. This is going to give me E1 R2 plus E2 R1 upon R1 plus R2. Since I have to bring V on left hand side and I on the right hand side, I'll bring this on left hand side. V 1 upon R1 plus 1 upon R2, and this is going to give me minus I here. So V, this is going to give me R1, R2, R2 plus R1 is equals to same value E R2 plus, this is E1, E1 R2, E2 R1 upon R1 R2 minus I. I have to keep only V on left hand side. So I'll take it on left hand side only V. V is equals to now E1 R2 plus E2 R1 upon R1 R2. This is being multiplied by R1 R2 upon R1 plus R2 minus I. This is going to give me R1 R2 upon again R1 plus R. This is further giving me E1 R2 plus E2 R1 upon R1 plus R2 minus I 1 upon R1 plus 1 upon R2. This can also be written like this. And now we compare it with standard equation. V is equals to E minus IR. So E equivalent will be equal to E1 R2 plus E2 R1 upon R1 plus R2. And what will be R equivalent? It will be equal to R1 R2 upon R2 plus R1, or 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2, either way. So internal resistance here you can see is adding in parallel. So internal resistance when the cells are connected in parallel will decrease and equivalent EMF will be of this kind. So I think in this way you might have understood how the cells are connected in series and in parallel. Try to read these derivations, and 2 questions I have given you. Try to do those questions, and we'll be starting a new topic tomorrow, that is the Kirchhoff's rules. That is how to find out the current in the circuit when more than one source of EMF is being used. In the meantime, I'll also convey you the things that during this time you can also prepare your project work. So I'm giving you 3 days. By Saturday you just find out some topic which will be related to your course, also may not be related to, but of this standard only 11th and class 12th, better is class 12th only. So you just finalize one topic so that you can make a project work on that. In the meantime, how to make the project work, that I'll elaborate in one more video. Thank you.